Hello and welcome to everybody on Cloud Fitness. So in today's video, we are going to see how we can do the data cleaning using some commonly used functions in the Databricks. So these are the functions which we mostly use on the day-to-day basis for the data cleaning operations. So without any further ado, let's go ahead and see what are the functions and how we can use them. So I have listed a couple of functions which we are going to discuss and we are going to see how they actually work. So you see here the very first is with column renamed and the next one is with column. The third one is init cap, cast, when, filter, expression, group by, aggregate, sum, sort, drop duplicates. Next we have distinct, drop na.drop, fill na.fill, regex replace, regex extract, rtrim, lower, upper, concat ws, collect set, collect list, flatten, exist, window, to date, literal, schema of CSV, schema of JSON, rank, substring, split, is null, if null, is not null, null if, from Avro to Avro. So these are the functions that we are going to discuss today, and we are going to see how these are commonly used to do the data cleaning operations. So if you see right now, I am in my Databricks notebook and I am connected to the serverless. So I have already explained serverless in my previous video. So in case you guys have not watched it, I do recommend watching my previous video on serverless. So if you see, here I'm just mentioning few variables. What is the name of my table? So basically for the data cleaning, I'm just making sure I have the right data set in the right table. So this is the data frame that I have. So this is the raw data, okay, that I have put in a specific table. And I'm just reading this data frame and we are going to do data cleaning operations on this data frame. So if you see over here, you have an year, first name, country, sex, and the count column. So now let's move ahead and see what we have. So the very first function that we discussed was with column renamed. So you can see over here, I'm using my data frame that I have at the top, and then I'm saying dot with column rename year as year of birth. So basically it is just used to rename the column from year to year of birth. With column renamed is specifically used to do the column renaming. Then you have the next function that I showed you, which that was with column. So now with column is used to add a new column, right? Now the column that you are adding, that column can be generated by addition of the two other columns or maybe some hard-coded value. So with column is just used to add a new column. So you can see here I'm saying dot with column first name. Okay, now this is the column name, first name is the column name, and the rest part is how that first name column data would be generated. So if you see this highlighted portion now, right, so init cap call first name dot cast string. So it is using three other functions. So if you see init cap, so it is making sure that the initial letter of the first name is a capital letter. Okay, cast is making sure that the first name is a string. So that's how a new column called first name is added. Now similarly, you can see here also in the next step, we have another column which we are adding using dot with column, right? Now with column and then sex is the name of the column, and how that column is how the data is getting populated. That is getting populated using this when function, using this when clause. So it is saying when column sex is M, then make the data as male. If it is F, then make the data as female. So what it is doing, instead of M and F, it is making the data to be male and female, MALE and FEMALE. That is what it is doing. And then we are displaying the data and then we are writing it in a table. So let me just run this so that we can see how these changes have affected our data frame. So now you understand I'm running serverless, so how quick it is. I don't even have to wait for the cluster start time. So you can see this year column has been renamed to the year of birth column using with column renamed. Then you have a sex column where M and F has been converted to male and female. We have already done that. And then you have first name column, which the capital letter, the first letter is capital, right? Now let's move ahead. And then coming on to the next, then you have what we are doing. We are using this data, the what we have got here, year of birth, first name, country, sex, and count. We are using this, and then we are applying a filter operation, a group by operation, an aggregate, a sum, a sort, a descending. So all of these I've shown you, right, on the PPT that, okay, these are the ones that we are going to discuss. So what's happening here? On the data frame, okay, I'm saying dot filter. Expression, filter what? I'm giving a certain expression, right? Now in this expression, I'm saying wherever year of birth is equals to 2021, filter that data for me. Give me that data where year of birth is 2021, and then group it by sex and the first name. Group it by sex and first name, and then aggregate. Give me the count. Give me the count, and then sort it in the descending order, right? And then I'm going to display it. So let me run this as well to show you how it is actually working. So the very first thing that you're going to get is the data is getting filtered, then it is getting group by it, and then it is getting aggregated, and then it is getting sorted. So if you see total count, we are trying to get total count of male whose first name is same and are born in year 2021. So what is the total count? 1359, and it is already sorted. So if you see the sort and descending has been applied. So so if you look at the output is in the descending order. I'm just scrolling down the output. So it's in the descending order already. So that is how you apply filter, you apply group by, and then you apply aggregation. In the aggregation, you have to have some kind of aggregations like sum, min, max. Similarly, you need to have a sort if you want to sort, and by default it is ascending order, but if it is descending, you have to mention it. So now let's move ahead and see what we have next. So next is drop duplicates, right? Now if you want to if you have duplicate data, right? So for example, if you see this is what we are doing. I'm just creating our data frame. So let me just paste it here and run it. So, and let me say display df. So what is happening here? We have a data, three rows, and if you can see that we have a duplicate over here, right? We have a duplicate, and I want to remove the duplicate. So in that case, I can simply say df dot drop duplicates. That's help you in data cleaning. Now, if you see the moment I run drop duplicates, you're only getting two rows. You're not getting the duplicate one over here, right? Now, another thing is you can drop a duplicate based on a certain column as well. You can drop duplicates based on specific column. So when I'm saying that drop duplicates, okay, it is taking everything into consideration. But now if I'm saying drop duplicates based on name and height, so based on name and height, drop the duplicates. Okay, now if you see everything is a duplicate based on name and height, because name is Alice or Alice, and then height is 80, right? So if I do in that manner, what is happening? All three of them are actually duplicates. So it is going to leave only one value. So let's see, and let me run this. So now if I run this, you will see that you're only getting one value in the output because it is considering everything as a duplicate. So it is randomly taking out one from it. So that is how drop duplicate works. So in drop duplicate, specifically, you can pass in the columns that, uh, you know, that you want to perform deduplication on, right? You can specifically put in those columns. But when you see distinct, right, even if you look at this distinct, in distinct also, what you can do is you can remove the duplicates using the distinct also, right? So many of you might have got this question that, hey, I can do it using df.distinct also. So now what is the difference? The difference is you cannot pass in specific columns. If I do df.distinct, it is going to give me the same output as drop duplicates, but I cannot pass in my name and height over here. That is what it is about. So let's move ahead and let me create another data frame and just simply run this to show you. So if you see, I'm running this where I am adding the data. So if you see age, height and name, and it has some null values. Now what we are going to do, I'm going to show you how you can clean the data by removing the nulls or by adding some other values in place of nulls. So if you see this particular data set, right, age, height and name, let me just do a display rather than show so that it looks little more structured to show you guys. And let me just rerun it. So you can see in the data you have age, height and name, right? So age 10, 5 and then you have null. In height you have 80 and rest you have null, and the name you have Alice, Bob and Tom and then you have null. So the moment I say df.na.drop, so this is also one of the function that I showed you. So the moment you say df.na.drop, what is going to happen? Let's see it. So it is actually going to drop all the rows that have nulls, right? So this is how it looks like. So the second row has null, the third row has null, the fourth row has null, and it has dropped it. So it has only gotten you one row, which is not null. So that is what na.drop does. And then another way is you can do either of these two, right? Either you can say df.na.drop or you can say df.drop and na. So that is why on the PPT also, if you see, I have said drop na or na.drop. So these two are nothing, but these two are essentially the same thing. So if you say df.drop na and inside it you pass a parameter any. How any? How you want to drop? Any means if any of the column is null, then just drop it. Okay, that is what it means. And that's why I'm running it right now. And you can see it has dropped the other two rows that has nulls. So now if I say df.drop na, how all means if all of them are null, then only drop it. So try to understand the difference between this any. Any means if any of the column is a null, then drop that. I don't want to see that column. All means if all of the columns are null, then drop that. So now the moment I run it, you can actually see what's happening here. So the other two rows are still visible. You can still see the other two rows because they don't satisfy this criteria, right? Because this criteria is asking that drop only if all of them is null. Similarly, the other way of writing is df.drop any threshold is equal to 2. Threshold 2 means that drop only if at least two of them are null. So you can see two of them are null even here, right? So it has dropped Tom also. Here you can see it has dropped Tom also, and when all of them are null, that part also it has dropped. So threshold 2 means where minimum 2 is null, drop it. So now let's move ahead. And then if you want to put a subset that drop only when height column is null. So if you see height column, if I go back to the main data frame, height column is null everywhere. Only in one row it's not null, right? So if you want to put a subset is nothing but the column. Okay, if you want to say that, hey, drop only if the height column is null, this is how you're going to mention it. df.drop in a subset equal to height. Now similarly, df.drop na threshold 1 subset is height or name. It means that threshold is 1, means at least one value should be null. One value should be null. If one value is null, then drop it, right? But one value of what? Height and name. That is how it actually works. So let me just execute this and you will see the output. So now you can see in the height and name with the threshold of 1, you can check the output. Height and name, you have got Bob and Tom. The reason being in this subset, not even only one row actually matched, because only one row where everything was null, only that row matched the subset where height and name was null. So this subset is considered as 1. So this is 1. Height and name is considered as one subset. Now where both of them are null, that becomes a threshold of 1 and just drop it. So let's move ahead, and then the rest is fill NA. So fill NA is actually used to fill in the null values. Okay. Fill NA is actually used to fill in the null values. Let me run it step by step to show you guys. So df.fill NA value 0 subset height. What does it mean? Wherever height is null, make it as 0. That's what it means. So wherever height subset is a column, make it fill it with value 0, and that's what has happened over here. Then the next one is, let me just run this one as well in a separate cell, although you can see the output in one go itself using serverless. But still I'm just making sure that I'm showing you step by step. So fill NA value to be empty. So now what's happening here? If you see, age and height are integers, so that's why it has left it null. Okay, so it is filling the string values as empty because name is a string, so it has put it as empty. Similarly, if you can see, let me run this. Fill NA, fill height with 1 2 3. Now why I have put it, I have put it because height and age is integer. Okay, so fill NA 1 2 3, age 25, age 45 dot show. So the moment I run this, you can see that age and height have been populated. The null values have been populated to 45 and 23, right? So this is what fill NA does. So let's move ahead and let's talk about regex.replace. Now regex.replace, as the name says, it tries to replace something. It tries to replace a regex pattern. Let me try to run this first. So here what is happening? I'm creating a data frame. So now you can see all the output is visible within the one window itself. So that's how serverless also works. So create data frame. So this is the data frame that got created. String pattern replacement. Okay. So string is 100 hyphen 200. Okay. This is the pattern. And then the replacement, I want to replace it with this. So what I'm going to say, df.select regex.replace, replace string, replace this str, okay, with whatever starts with a number and has anything. After that, replace it with this hyphen hyphen and alias rename it as D. So that's what has happened here. So it is just replacing this value using this pattern. Using this pattern, it is replacing this value and putting hyphen 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 here. Similarly, uh, you can check any pattern, this D. So there are certain patterns. If a number is there, then this is the pattern. If a capital letter is there, that's a pattern. If it starts with, then the caret symbol. If it's 0 or more character, then it's question mark. So like this is called as regex. It checks for a certain pattern. If it matches, then it replaces it. That is what it has done. So now let's move ahead. So here also, if you see regex extract, so you can see it is extracting something, right, out of the data. So this is your data frame that got created. So if you see, let me in fact show you the data frame first and run this. So now you will be able to see the entire output. So now let me show you. The very first thing what happened is we created a data frame. What is a data frame? String 100 hyphen 200. Now regex.extract, extract the value from str column. Anything that starts with a number has hyphen in between, and then there is a number again, right? Extract the first value out of it and then alias it as D. So the first value has been extracted, which is nothing but 100. That is how this regex work. Then again, if you see here, what is happening? Create a data frame foo. In fact, again, let me put a show over here so that you guys are more clear on these two data frames as well. So now you can see what has happened here. We have created a data frame. This is the data frame. Let me show you the output. str foo, and that is a value. So there is a data frame, and then I'm saying regex.extract from this column str. Extract what? Using this pattern, extract the first value. First value should be what as per this? The first value should be a number, but now there is no number here. Okay, so what it extracted? Nothing, because there's nothing, right? Similarly, there's another data frame which is AAAC str, right? So now let me come down to show you how this is the data frame straac. So this is the value. And then if I go up, you can see regex.extract from this string something that starts with number, right? So every something that starts with words. So you can see and the second value out of it, right? But then there is no second value over here. Okay, it is saying a plus is the words, but there is no second value. So hence it is returning you 0. When I say 0, it's returning empty, right? So that is how this regex helps you to extract the value. It exactly works like Python only. Similarly, the next is trim. Okay, length. So these are again the data cleaning functions which are used commonly. So create data frame. So first what you have done, you have created a data frame. Let me show this data frame as well. So when you create this data frame, you will see that in this data frame, there are a lot of empty spaces, right? And then we are trying to trim those values. So if you see this value, there's an empty space at the left side, there's an empty space at the right side, and then there is an empty space at the left side. So there's a space, right? Now, if I'm saying df.select trim value, trim is the column name. Alias is helping you to rename the column. Okay, to rename the column, alias can also be used. So if you see this alias, it is renaming the column to R, and the moment you say trim, anything that has an empty space in the data from the front or from the back, it is getting removed. Okay, and then with column length, it is adding a new column length. And then what it is calculating, it is calculating the length of the word, the length of the data. It is calculating length of the data using the length function. So if you see length, R, and that is how you got this data frame. Similarly, let's move ahead, right trim, R trim. In the same manner, you can put in R trim. So earlier we have put in trim. Now we have put in R trim. R trim means trim from the right side. That is what R trim means. So if you see here, Spark still has the empty space. So now you can see here it did not have empty space because that was removed from the front also. But here it is removing from the right side of the word only. It is not removing from the front side. So if you see the front here, we have the space, right? Front, we have the space, but what it is doing, it is removing only from the right side, not from the left side. And if you look at the length, okay, so just because if you see it has a space here, right, so it is calculating the space in the length. Okay, in the second word, Spark has only 5 words, right side it has removed the space, so hence it is giving you length as 5. In the third word, there is a space. Initially, it has not removed the space. But right side, there is no space to remove. So 5 words from Spark and 1 space from the left side. So like that, you can see how your L trim and R trim works. L trim means remove from the left. R trim means remove from the right. Let's go ahead. So when you talk about this particular data frame, right, you have PySpark, Spark, Pandas API, string, lower value. Lower means the lower function is put on a column name. So you can see column name is value. So lower value means lower function or the upper function is used to make everything to the lower case or to the upper case. So in this case, we have put lower, and then the likewise you can put it as upper as well. So even if you put it as upper, it is going to work and it is going to make everything in the upper case. So let's try this out with the upper right now. So you can see here the value have been put into uppercase. If you want, you can put it in the lower case. So this is also an init cap is actually going to help you to make the first letter capital. Now concat ws. So concat ws pretty much is straightforward. It is helping you to concat, right? The very first thing is we are creating a data frame here, a b c d 1 2 3, right? Now in this data frame we are saying that concat ws, concat the value in that data frame with a hyphen. So there should be a hyphen in it. Okay, concat whatever is the value which is present in the first column and then whatever value is present in the second column. That's what it is all saying. So S and D is nothing but it's a column name. So let me in fact show you. If you see this, and this is going to help you visualize it a little better. So now you guys can see what has happened. First, we have created a data frame. S and D is the column name. And then we are saying concat WS. Okay, with separator. WS is nothing but it's a with separator. With separator means when you're joining these two, then there has to be a separator in between. That separator is a hyphen here. Take data frame.s, take data frame.d and alias it as s. So this is what the output looks like. Similarly, if we go further, okay, for the arrays, let me in fact again display this. Whenever you're working with array, then also you can use a lot of different functions. The commonly used one is array sort, for example, collect set. So if you see, instead of collect, let me put here show. So if you see here, we have a data frame where you have the age column 255, right? You have a column which is nothing but 255. Now I'm saying collect set, okay? Collect set, I'm collecting it as an array first. Okay, I'm collect set is actually going to help you to collect the data. Okay, collect the data, and it kind of help you in combining the data which is present in multiple rows into a single row. So what it has done, it has aggregated, when I say aggregated, combined the data from multiple rows into a single row. Okay, it has got you 2, 5, and then array sort has sorted the array. It has made sure that you have sorted array, like the 2 is coming first, then it is fine, and then it is aggregating it based on the value itself over here, and then it is saying basically collect set is mostly used with the aggregation only, and then you're aliasing it. So that's how you can actually use the array sort as well. Similarly, you can also use collect list. Now collect list and collect set, right? The difference is the collect set is always going to give you distinct record. So if you see here, you have 255, right? But here in the output you have only 25. But now if you look at this collect list, what it will have, it is going to have collect list here. The input is still the same, but the output is having the duplicate value as well because of collect set and the collect list difference. Similarly, if you go ahead, so if you can see there's a list over here, right? Now this is how the data looks like. It's an array, 2D array. Now if you see, if you want to flatten it, so you can simply say df.select flatten df.data. Now what it is doing, it is helping you flatten out the data. So this is just helping you to flatten out the data. From 2D array, it has put it as a 1D array. So flatten helps you to flatten the data. Similarly, the next function is, if you see here, exist. Okay. Now you have a data frame. Exist helps you to evaluate a situation in a true or false. Okay, so if you see this create data frame, it has first created a data frame with the key value pairs, and then it is checking whether whether there is any value negative or not. If there is a negative, it is going to return it as negative. Like if it is negative, and it is going to tell you that hey, it is negative. That's why it is giving you true for the second set. For the second set of key value pair, it is saying that hey, that yes, a negative is present over here. That's why it's returning you true. Similarly, again, if you want to see how window function works, group by and window, so this is how it works. So if you want to group by and you want to use a window function, right? So what is going to happen is it is mostly used with the aggregation. So at the very first place, we are creating a data frame here. Create a data frame, date and the value. Okay. Now df.group by window date 5 second aggregate sum the value alias sum. So what exactly it is trying to do? It is trying to do the aggregation. It is adding the 5 seconds, for example, to the date. So here if you see 2016, 3rd, 11, 9, 9 is the time. So it is making sure that it is doing a window on the time period for 5 seconds. So 9 hour 5 seconds. And then it is getting the value, and then it is casting it as a start time and end time to show you guys. So let me in fact put it this way, and let me just simply run it so that you guys can understand it better what I'm trying to show you guys. So if you see this spark.create data frame, okay, date and the value. So this is the data frame exactly. Now w.select window.start. So this is the window. It is taking the window of the date. So from here it is deriving just the date. Okay. So from this date, it is taking the 5 second and it is aggregating the value for 5 seconds. And then here it is saying cast it as a start date. Okay, cast start as the start date, end as the end date. So this is the start, which is your 9, and the end is coming as 9 hours 7 minutes. 9 hours 7, 9 hours plus 5, not 7, because it is taking the window of 5 seconds. So it is taking the date from here, and then it is saying that hey, start time is nothing but date plus 5 seconds, and the end date is nothing but the window of start plus 5 more seconds, because it is doing a aggregation as well. So these are the different ways in which you can use windows, cast, aggregations as well on your data set. Similarly, here also if you see, it has created a data frame first and then df.select to date. So this is the input. It is converting everything into a date using to date function. So to date, since it has timestamp, but using the date, to date, it has converted that timestamp also into just a specific date itself. Now similarly, literal. So there's a function called as lit. This lit function helps you to put any hard-coded value. So inside this lit, whatever I put, that will be considered as a hard-coded value. So you can see df.select lit5 alias as height. So what's happening here? 5 is getting added as a height. So whatever you type in here, even if you type in 15 here, it's a hard-coded value that gets added. Okay, so if I say range 5 and let me just run it. So what you will see that this lit of 15, okay, will get added. So you can see for every ID, this lit of 15 is getting added. Why? Because this is a new column which is added, which is height. It is added with respect to ID and it has been hard-coded to 15. Similarly, the next is schema of CSV, schema of JSON. This can be used for a schema of JSON or CSV both. So you can see schema of CSV helps you to show you how that schema actually looks like. Okay. So let me just in fact add a display over here. So if you see schema of CSV, it has created a CSV first of all here. It is saying literal 1 pipe delimiter A, and then the separator is, pipe delimiter. It is telling you that it is a pipe delimiter. So then if you see here, it tells you the schema, how the schema of that particular CSV is, right? It explains you that. Similarly, if you see over here, it's pretty much the same thing, but the only difference that you see here is that I've added a show command instead of display, right? But it just helps you to show the schema of a CSV, schema of a JSON. You pass in that JSON over here, the information over here, and then you'll be able to see the particular, schema of CSV or JSON. So it's mostly, it will tell you how the data is actually looking like. And I think window I have already explained you, but yeah, if you guys want to check out the rank, even rank is also most commonly used. So it is if you see here, a data frame is created 1 1 2 3 3 4, and then order by value. Okay, window, order by value. So order by value is nothing but it is ordering it in the ascending order by default with column D rank over value. So it is calculating just like your SQL rank. Okay, the rank here, you can add row number, you can add rank, you can add dense rank. So likewise, this helps you to rank your data. Okay, this is a very commonly used function again. Similarly, if you see substring, right, if you want to get substring, now this is your data frame, A B C D is the value. Okay, now you want to get something out of it. Now, if you want to get some specific value out of it, how you would do it? You would say df.select substring from this column of the data frame, give me the value which starts from 1 and ends with 2. So what starts from 1? A and B. So it is giving you A and B as the output. Okay. So it is going and iterating through the row over here. Whatever is the row, it is going and it is iterating through this row. It is taking the first value and the second value and giving you the output. Starting with the first, ending with the second, and giving you the two values. So that's a substring. Similarly, if you want to split, so if you see the data frame has this data 1A, 2B, 3C, right? This is the data. If you want to split it, how do you want to split it? You use a split function here. So you say that go to this column, okay, go to this, and now, so go to this column df.s, right? It is telling you that, hey, go to this column, split it using these values A, B, C. So wherever you find A, B, and C, just split that particular column, but split it until 2. Similarly, here it says split it until the end. So what happens is, now if you can see, when you said that split it until 2, right? So then what is happening? If you see 1, 2B, 3C, it has only split it until the first value here. And if you see this, -1 is nothing but it is called the end, right? If you guys know Python and the listing, then you would understand it even more easily. So if you see this -1, it has taken the entire value, and wherever it has found A, B, and C, it has split it. That's how your split works. Now, if you guys see, um, this is a pattern, right? This is your actual word 1A, 2B, 3C. This is actual pattern that you want to split. ABC is the ABC is the pattern that you want to find in this particular word to split it. -1 means the entire word you want to split. 2 is the number of times you guys want to apply it. The number of time you want to apply the split. So here you see how the split is applied over here. So 2 is the number of time you want to apply the split. The -1 means the entire length you want to apply that particular split. Now, if I go forward, again, the literal I have already explained is the hard-coded value. If null, right? Again, if null helps you to check. So if you see, to check the nulls, now if you see spark.create data frame. So there's a data frame that got created, right? So you can see a data frame got created. Now it is saying that if there is anything is null over here, okay, if it is null, then make it as default literal 8. That is what it is doing. So if you see, there is a none over here, and by default what it is doing, it is making sure that the output is 8 over here. Similarly, if you proceed ahead, select is not null. If it is not null, if you look at this, the very first thing is the data frame that is getting created, none and 1, right? Now is not null, okay? If it is not null, then tell me. Now is not null is going to give you true false as an output. If it is not null, okay, then it is going to give you false. If it is null, it is going to give you true. So these are few ones which you can actually use on day-to-day basis and try to understand how you can do data cleaning. And in fact, these are the most commonly used ones for the data cleaning. Again, if you see create data frame over here, right? A data frame got created here, none, none, 1, 9 as the value. Select null if, okay, null if df dot a, df dot b. So it is taking in the values. So these are the columns, right? A and B are nothing but the columns. Now these are the values of your A and B columns. So if you see what it is saying, null if, so if it is null, if this df dot A is equal to df dot B. So basically, if I'm saying if none is equal to none, then it is going to return me null. Otherwise, it is going to return me the first value. That is what it is all about. So if you want to understand it, let me say display and df. So it will give you a better picture. So if you see, this is how my data frame looks like. So what it is trying to do, what does null if do? If A is equal to B, then it is going to give me null. Okay. If A is not equal to B, then it is going to give me the first value. So 1 is not equal to 9. Hence, it is going to give me the 1 as the output. So similarly, there are other functions as well. To Avro, from Avro. So there's a data frame. it has using two Avro function. What you can do, you can convert it into a binary format, which is nothing but a Avro format. This is how it looks like. So this is just a normal data frame that got created. From that data frame, we have using two Avro function, we can convert it into a Avro binary format. So if you can see, this Avro df is nothing but it's a binary format that got created. Okay. Similarly, from Avro, so if there is already a Avro format, okay, from Avro can also help you to get the data in a JSON format. So you can see from Avro it has got you the data in a JSON format. So this is how basically here using from Avro you're trying to fetch the data into a JSON format. It is just trying to it is trying to take the data from an Avro format and load it into a JSON format. So I hope you understood these functions. These are most commonly data cleaning functions which are used in the Databricks. So I hope you like this video. You guys can go ahead and practice them as well to learn. So thank you so much for being till here. Do remember to like, share and subscribe my channel.